This is an exercise on the applications of sinusoidal functions, the second one. So kind of a continuation of what we did previously, but with the equations and the graphs just a little bit more complicated. So I'm going to launch right into a couple examples, not do much background on this. So here we have an equation comparing the depth of water t hours after midnight. So this is another one of those tide problems. But here the equation is a little bit more complex. So h is equal to 1.8 sine bracket 2 pi t minus 4 over 12.4 plus 3.1. The instructions are to find the amplitude, the period, and then sketch. So let's do this. By inspection of the equation, we should be able to get the amplitude pretty much immediately. The amplitude is equal to the absolute value of A, so that's equal to 1.8. Now the period, more complicated, but not too bad. You see, the period is always equal to 2 pi divided by b, but you have to make sure that you get the b value. And the b value is in fact that whole thing, that 2 pi over 12.4. So this would be 2 pi divided by 2 pi over 12.4. So when you worked out the complex fraction, that becomes 2 pi times 12.4 over 2 pi. And so therefore that's equal to 12.4, and in this case it is hours. So it's cycling pretty much every 12.4 hours. In order to sketch it, we do need to get our window settings down, and we've seen this many times before, or at least several times. The x minimum should be the negative period. It's not carved in stone. Some people will make the x minimum just a bit to the left of 0 because they're not interested in negative values, and fair enough, but I'll stick with this and adjust where necessary. The x maximum 12.4. The scale is the quarter, so I just go 12.4 divided by 4, and as before, I let the calculator do the work. The y minimum, choose a reasonable y minimum for a question like this. With an amplitude of 1.8 and a vertical translation of 3.1, we're really not going very high up. So you could do and far down. So I'm just going to go my y maximum to be 8. And I'm going to do my y minimum to be -5. So don't fret too much over that. If it's the wrong value, then when you graph it, you're not going to be able to view your graph. So you can always change it afterwards. And then the y scale, because those numbers aren't very big, I'm just going to have a scale of 1. And this is how we enter it. There are choices, but I like to do it basically as it was written. 1.8 sine, open bracket, or the bracket opens for you, 2 pi, open bracket again, x minus 4, close bracket. So I've got my numerator there, and then this is divided by 12.4, and then close that bracket, plus 3.1. It would have been possible to go 2 pi, if you preferred, divided by 12.4, and then open your bracket, x minus 4, if you like, because that keeps the b value together, but it really doesn't make much difference. So when we do graph it, you'll get something looking like this. Obviously the scale won't be as clean, you won't have those values written on it, and you won't have the nice labels, depth versus hours after midnight. But the scale, it should look somewhat like this, give or take a bit of a perspective thing. I'm also not going to bring this up on my calculator. We're not finished though. The next question is to find the maximum and minimum depths to the nearest tenth. Now, this really is the range, even though it didn't specify that. because in order to get the maximum, you're really just dealing with d plus a. Now you can use your calculator to find these ones. You have a max and min key, so you're welcome to do that, but it shouldn't be that big of a job. And then the minimum is d minus a. So really all we're doing to get the maximum is taking that d value, let's work that out, 3.1 plus 1.8 is equal to 4.9 meters. And then the minimum would be the 3.1 vertical translation, which is really just the midpoint of your curve. And then we subtract the 1.8, and then that will give us 1.3 meters. And if you were to look at your graph, you could certainly tell that this was these are reasonable numbers based on what we have. Now, part C is asking us to find the depth at 5:45 a.m. to the nearest tenth of a meter. Now, we have to be aware of something. This 5:45 is in a time unit, and we cannot enter that directly on our graph or our calculator because it has to be decimalized. So decimalize 5:45. So that's 45 over 60 minutes for 1 hour. So when you divide 45 by 60, it's 5 3/4 or 5.75 hours after midnight. This is the figure that we will use in our calculations. So again, I'm going to use my trace key. So anytime you're given the x value, usually time, and we want to find the corresponding y value, say height or voltage or whatever it is, the value key works great. So all you do with your graph up there is you are viewing your graph, you press trace, and right at the bottom, of course, you get these x numbers, and then press 5.75 and press enter following that, and then it gives you the y value. So you can use that for any x value along the curve. As long as it's on the window, within the window settings, you're fine. And according to that, I get y is equal to 4.495. So that's telling me that the depth is 4.5 meters at 5:45 a.m. The other choice would have been to go into the equation and plug in x right into it and solve for y. But the reason I didn't do it is because I had the equation on my calculator when I was graphing, and it made more sense for me to keep it there rather than to just enter it in sort of in a regular calculate mode. So anyways, what this is really just telling us is that at 5:45 a.m., which is, this isn't a very easy scale to work with. In fact, if I was doing it again, I might change it to just have regular hours. But no matter, when at 5:45 a.m., so that's just a little bit before 6, the depth is 4.5. So, somewhere around there. Seems reasonable. Now the next question, D, is where things get even more complicated. When does the depth first reach 3.5 meters? So this is problematic because we need to find x when y is equal to 3.5. And our calculators are not set up to do that directly. And if you did it algebraically, that is, if you replaced the height with 3.5 and solved for x, you would have a very complicated trig equation on your hands. So what I'm going to do instead is use my intersect key. In case you have forgotten, and I hope you have not, this is found in your calculate menu. So if you go into calculate, which is second function trace, you do see number 5 is intersect. So you have to enter the second equation, which is y2 is equal to 3.5. So that's just a linear line, or a line, that's just a horizontal line, and you should end up something like this. the two graphs right on your grid. And we want to find out the x value right there, where they do meet. So that's with that arrow. And once you go into your intersect key, so calculate then 5, it requires you to locate it with your cursor. So you just move your arrow there. Now, because I believe everybody has done this before, I'm not bringing up the calculator to look at it. But put your cursor there, right as close as you can to the intersection point, and press enter 3 times, because it's your first curve, your second curve, and then guess. So you don't have to move it around. And then you should get, as a result, x is equal to 4.44. That's what I got. And then if you take that to the nearest tenth, we could say that the depth is 3.5 meters at 4.4 hours after midnight. Now, I know that I didn't convert that back into sort of regular time units, which would be like 0.4. You'd have to, work that out into a unit of 60. But this is good enough. That's the way most of them are expressed. And there we are. And it, by the appearance of the graph, that certainly seems like it could be right around 4.4. So that's getting close to 4:30 a.m. Going to change gears in the next one, because those ones gave us equations. This one does not give us an equation. It gives us the graph. Now, we've done lots of these before, but just not in a context of not in the context of an application. So this is the path of a person in a Ferris wheel, and it's graphed as we've got it shown. Now, the idea with a Ferris wheel, usually, but not necessarily, is that you get on at the lowest point, and then as time passes, you go higher and higher and higher to a point, and then you go back down again. So even though it is a circular path you're actually traveling, in terms of a graph of height versus time, you would have a sinusoidal wave. And the question goes on, if a rider gets on the wheel at the lowest point of the Ferris wheel, which we can see from the graph, but it should be explained, and this is at a height of 11 meters, and reaches a maximum height of 34.5 meters after 9 seconds, we want to find 2 equations to describe this path. So back to the graph. Now we do this the same way that we always do them. We find our D value, we find our A value, and we find our B value or C value. So I'm going to start with D, and it's just as easy to find A to begin with, but D I'll go after. And D is equal to the minimum value plus the maximum value divided by 2. So D is equal to the minimum value of 11 plus the maximum value. If you go back to the previous description, they say it's 34.5. So 34.5 and then divide by 2. And all you're doing is getting the midpoint. And frequently, usually, you can just work that out by inspection, but this is a little tougher with those numbers. So 11 plus 34.5, enter, divided by 2, will give you 22.75. So that means somewhere around there is the midpoint of our curve. So there's D. Now the amplitude can be found a number of ways. A lot of people will just take that D value and subtract it from the max. But you can do it the more formal method, which is max minus min, and then divide that by 2, and that will work also. Do not make these more complicated than they really are, because it is mostly simple reasoning power that you use to solve them. So don't think formula so much, just think, well, if somebody was offering me money to solve this, could I find a way? And I think in most cases the answer would be yes. So I'm getting an A value of 11.75. You don't need to be reminded, but I'll tell you anyways. You have to press enter after you key in the 11. And also remember that the A and the D value do not change for any graph. Now we have to find what the B value is now. And to find the B value, we need to get the period. And this thing did not give us the full period. So we have to get the period from this. And we have 9 seconds from the bottom to the top. This is 9 seconds, but this is 1/2 the period. So to find the full period, we multiply by 2, that 9 seconds. If it takes 9 seconds to go halfway, multiply by 2 is equal to 18 seconds. And then all we have to do to get the B value is go 2 pi divided by that period, which is 18. So B is therefore equal to pi over 9. And those 3 values do not change. So let's put this whole thing together. Now our graph is centered at 22.75. It's true. So if we wanted to call this a graph in its simplest form, we should be aware that this is a form h at t equal to a cosine curve. And the good news with this cosine curve is if we make this negative, and I'll be theta plus d, should probably use a t for the theta, but okay, I'll change that. The next one. If we treat it like it's a reflected curve, because notice how the trough or the minimum value is on the y-axis. So with no translation, we could just go negative 11.75 cosine pi over 9 t plus 22.75, and then we are in business. We've got a good equation for it. Now the other choice would be to call this one, well, we could call it a cosine or a sine or whatever, but I'm going to go sine because I don't want to. I know you're probably thinking that the easiest form might be to have a horizontal translation of 9 and call it a positive cosine, and you're right. But I'm going to look for this point here and go a form sine a positive sine curve. So h at t, fix that up, is equal to a sine b t minus c plus d. So we need to find out what this point is there. And we do so by noting that if the period is equal to 9, or 18, excuse me, 18 seconds, if you divide it by 4, your quarter, 18 divided by 4, is equal to 4.5 seconds. And that 4.5 is critical because that 4.5 is giving us all the stops along the way. There, there, there. If you went further, even there. So you could change it to whatever you wanted based on that 4.5. So for a sine curve, it means that there has been a horizontal translation of 4.5, so b is still pi over 9, and then t minus 4.5, close, close, and it's a little tight there, but I'll go plus 3.1. Oops, plus, try that one more time. H at t with a bit of space. H at t is equal to 11.75 sine pi over 9 t minus 4.5, close and close, plus 22.75. And then you've got it. And once you have that equation, you could do whatever you want to it. Exam questions typically will ask for 2 equations to match that one graph. So I'll stop right there. So thank you for your